Welcome to week 3, lesson 1, the distributive property. In this lesson, you'll be able to use the distributive property and you'll be able to combine like terms. So first, let's look at the distributive property. What is the distributive property? Well, we're going to look at 3 numbers, A, B, and C. So we're going to, what we're going to be doing is we're going to be taking one of the numbers and multiplying it by the quantity of the other 2 numbers added together. So that's what this is showing. A times the quantity of B plus C. Well, that's equal to A times B as well as A times C added together. Well, let's take a look at some real numbers to see how that works. So I'm just going to choose A is 3, B is 20, and C is 5. And we're going to evaluate this expression to see if both sides remain equal. So we're going to put 3 in for A, 20 in for B, and 5 in for C. Order of operations, we could figure this out. We could figure out that this is 75, right? 20 plus 5 is 25. We would do that first. And then we would do 3 times 25 and get 75. Well, is that equal to the right side of this equation? So let's look and see. Well, this is saying 3 times 20, A times B is 3 times 20 plus 3 times 5. Well, what's 3 times 20? That's 60. 3 times 5, that's 15. 60 plus 15, just like we said at the beginning, is 75. Now, a property that we learned about in the second week was the commutative property, which says that I can reorder the expression and it remains the same. So B plus C times A is the same as A times B plus C. So the distributive property can work either way like that. And just so you can see it, if you want to pause and take a look at this, it ends up being the same. The distributive property actually works with subtraction as well. So A times, instead of B plus C, we have B minus C. That's equal to A times B minus A times C. And again, we can look at the work here. I'll go through this one a little bit. 20 minus 5 is 15. 3 times 15 is 45. So we can figure that out just looking at the left-hand side. We look at the right-hand side. 3 times 20 is 60. Minus 3 times 5, which is 15. 60 minus 15 is 45. And just like with addition, the commutative property can work here. Now, you might be thinking, the commutative property doesn't work with subtraction. Look at what we're switching, though. We're not actually switching the subtraction. It's still B minus C. What we're switching is the multiplication. So A times B minus C, and then B minus C times A. The commutative property works with multiplication. And that's really what we're switching here, is which one we multiply first. And you can, again, pause and look at the work here to see that it does, in fact, work. So let's look at an example of the distributive property involving fractions. So we've got 1/6 is like our A, X is like our B, and 13 is like our C. So A times B is 1/6 times X, plus A times C is 1/6 times 13. Well, multiplying fractions, that X has like a 1 underneath it. You probably should remember that from the class before this. So I can multiply 1 times X, those are both in the numerator, and you see 1 times X, and then 6 times 1, which just gives me 6, and that remains in the denominator. Same thing with the second part. 1 times 13 in the numerator, 6 times 1 in the denominator, and then simplify. 1 times X is 1, X, or just X over 6, plus 1 times 13 is 13 over 6, and that is simplified using the distributive property. We can actually go one step further because the denominators are the same. Since the denominators are the same, I can put X and 13 together to say X plus 13 over 6. Now, we just took a little look at fractions, so I'm going to take the time to explain that a little bit. What do we know about fractions? Well, we learned earlier in this semester that fraction bars are like grouping symbols. The numerator has like an invisible parentheses around it, as well as the denominator. We do those things first. And a fraction bar is division. It indicates division. So let's take a look at this. A over B. It's a fraction. Well, I could rewrite that as A times 1 over B. I kind of did that backwards. I started here and moved to this in the previous slide. A is in the numerator times 1 gives me A in the numerator over B. So these two things are the same. Quick look at some numbers, 12 over 2. We know that's 6. We know that. But we could also write it as the numerator times 1/2. I'm going to show you that because there will be times when that's useful. All right, so we're going to rewrite this using the distributive property. So 9x plus 11 over 2, I could rewrite that as 1/2 times 9x plus 11. So I'm taking the numerator and setting it off to the side and making this remaining part 1/2. Kind of like I did. I'll go back a little bit here. Numerator, whole number, and then the remaining part is the 1/2. Now I can distribute the 1/2 to the 9x and the 1/2 to the 11. Simplify that a little bit. I get 9x over 2 plus 11 over 2. And you can see that this expression here is the same as this expression here. Another thing that students have trouble with is this multiplication of -1. It doesn't look like this is a -1, it just looks like a negative sign, but in reality, that's a -1 in front of the parentheses. And we have to distribute that -1 to both the 4y and the -7. Now, I want you to get used to looking at this number as a -7, not as a -7, but as a -7. If you can do that, it's going to simplify things quite a bit. So -1 times 4y minus 7. So -1 times 4y plus -1 times -7. Again, look at that -7 as a -7, not as a -7. -1 times 4y is -4y plus -1 times -7 is +7, so plus 7. So that's distributing a -1. It switches both of the signs inside the parentheses. Last thing we're going to look at is combining like terms, a skill that you will need as we get to equations. Terms are separated by addition and subtraction signs. So here's an example. It's a very complex expression. It's still an expression here. We won't be dealing with anything like this until second semester, really, but I'm showing you how we can combine like terms here. Now, how many terms, first of all, are in this expression? Well, if I count 1, there's a plus, 2, another plus, 3, another plus, 4, minus, there's 5, plus, there's 6, there's a minus, 7 terms. So there are 7 terms in this expression right now. But there are some terms that are the same. To combine the terms, the variables, so x and y, and the powers, so the exponents, must match exactly. So if I'm looking at this, 3x squared, what does it match with? Well, it does not match with the x because, yes, the variables are the same, but the exponents are not. So I cannot put those together. So if I look further down the line, the only one that has an x and an exponent of 2 is the 5x squared. And I put those together with addition. So it's positive 3x squared plus 5x squared, which gives me 8x squared. Move on to the next one, 7x. Is there any other term that has just an x? And you can see that there is a -2x. And notice how the sign was also highlighted. So this is 7x plus -2x, which is 5x. Positive 5x. 6xy. There are no other xy's in this expression, so that one just drops down. That's positive 6y. And then I look at 9y and -y. That's 9 plus -1, which gives me 8y. You will have to do that, again, with a lot less complex expressions, but you'll have to do that in order to solve certain equations. And that is the conclusion of lesson 1.